Hello everyone. On behalf of SolidCAD, I would like to welcome you all to today's webinar, which is about the workflow between Plant 3D and Navisworks. Thank you very much for registering, and it's a pleasure to have you all here. In today's webinar, I will show you Plant 3D and Navisworks products, mainly focusing on the workflow between these two products. I'll make sure to highlight the best practices, do's and don'ts, tips and techniques so that you can work with these products without any hiccups. Here's the agenda for the webinar. I'll start with brief introductions. My name is Junaid, and I'm a technical consultant for Autodesk Plant and Manufacturing Solutions at SolidCAD. With me joining in this webinar as a panelist is my colleague Syed Rizvi. He is the product manager for Plant 3D at SolidCAD. For the next few seconds, I would like to hand it over to Syed, who would like to briefly introduce himself, and then I will jump into the software to show you the live demo.
Good afternoon, everybody. Thank you, Junaid. My name is Syed Rizvi, working in SolidCAD from last 15 years. I'm the product manager for the plant solution here at SolidCAD. I hope everybody is doing a social distance and keeping themselves and their family safe, and always keep healthy, stay at home. With this, I will hand it over to Junaid to take you through the presentation. And after that, if you have any question and answer, please leave us a note so we can come back to you and reply you with the solution. Thank you, and hand it over to Junaid.
Thank you, Syed. With this, I would like to start the live demo. Please be informed that you're welcome to ask questions in this webinar, and we'll be more than happy to take a look at the questions in the end. Just like Syed said, as long as the time permits. Duration of the webinar is 30 minutes, so just in case we run out of time, we'll still be getting in touch through emails with all those who ask questions, and we'll try our best to provide you with the answers to your questions. First of all, I have a quick poll question for all the attendees. Give me a moment. I'm going to launch the poll question right now because I just want to see who's using what, and you'll have about 10 seconds to provide your responses, and you should see this question on your screen right now. All right. So I have received the responses, and it's great to see that majority of the attendees are already using Plant 3D and Navisworks. So I'm going to close the poll now, and let's start the live demo. Okay, so here in my machine, I have loaded an example project in the project manager, and I'm going to use this project for today's webinar. Under the Plant 3D drawing settings, I have a subfolder structure available for storing different kind of files. And inside the steel structure folder, I have a structures drawing. I'm going to open up that drawing first of all. So the structure that you have in this drawing has been created using the AutoCAD structure module. And this structure drawing has been attached as an extract into my equipment drawing, and I have used it as a reference to place my equipment. And I'm going to start by placing a couple more equipment, and in the next steps to follow, I'm going to attach the equipment drawing and the structure drawing both into my piping drawing, and use these drawings as a reference to start placing my pipe runs and pipe supports. So let's start by placing the equipment first of all. So I'm going to click on the Create Equipment button. On the dialog box that pops up, I'm going to select one of the subtypes of the pump. I'm accepting the defaults for the dimensions, but I'm going to define a tag number. And I'm going to place this pump in my drawing by typing the X, Y, and Z coordinates on my command line. Oops. Sorry about that. Here's another try. Forgot to type the feed sign. There you go. So the pump is drawn, and when I hover the cursor on the pump, it shows me the tag number. I'm going to make a copy of this pump by using the AutoCAD copy command. And could be a nice idea to have the ortho mode on. So both of the pumps are straightly aligned. So I'm going to define a distance. All right, on the copied pump, when I hover the cursor, the program shows me a question mark, which indicates that the tag needs to be changed because I cannot have the duplicates. So I'm going to go to the right-click menu, assign tag, and I'm going to make sure that this pump has a different tag. Click assign, and the tag is assigned, and tag is assigned for this pump as well. So at this stage, I'm going to save and close the equipment drawing, and I can close the structure drawing as well. Obviously, we don't need to have that open always. And I'm going to go inside the piping drawing, which is totally empty. And I'm going to start by attaching the structure drawing and the equipment drawing as XREF. So let's start by attaching the structure first. Structure drawing is attached, and then I'm going to attach the equipment drawing as well. That is also attached. Once that's done, I'm going to change the view using the navigation cube, and I'm going to draw the first pipe run, which is going to be connecting this vertical tank with this horizontal tank. So I'm going to start by routing a pipe run on this nozzle. Seems like it's 6 inches, so I'm going to make sure that the size and spec is correct on my part insertion panel, route pipe, and I'm going to snap to the node. And after that, I'm going to rotate the compass to define a vertical drop of 6 feet. And I'm going to rotate the compass one more time to make some adjustment to the view. And then I'm going to define the length of this pipe run. And from here, I'm going to use a little bit of auto routing and snap to the node of the nozzle on the horizontal tank. And I'm going to accept the next placement, and the pump is drawn. After that, I'm going to click on this vertical pump and click on the plus sign grip, and I'm going to attach this pipe to the other pipe available, and the program automatically inserts the T. When I click on the T, I can also substitute the T to a reducing T. So I'm going to substitute that to 6x4 reducing T, and the program automatically places the reducers because the pipe is still 6 inches. I'm going to select this pipe, and I'm going to go to the properties, and I'm going to change the size of this pipe to 4 inches nominal diameter, and the reducers are gone and pipe size is changed. Next, I'm going to place a couple of inline fittings. So I'm going to go to my tool palette, scroll all the way down to find the globe valve flange, and I'm going to place it on this pipe. Define the rotation of the hand wheel, and I'm going to place the same globe valve on this pipe as well. And you can see that the program automatically adjusts the size of the globe valve according to the size of the pipe. I'm going to end this pipe run by placing a couple more valves here. So one over here, and then I'm going to draw another one here, and that pipe run is finished. Now, if I want, I can start assigning all the properties and the tag numbers to the valve and the line number in case I want to see that on the ISO drawing. I'm going to go ahead and place another pipe run to connect these pumps to the exchanger. So I'm going to just going to check the size of this nozzle. All right, so the size is 4. So I'm going to select the flange check valve. Okay, and I'm going to place another one here. After that, I'm going to select the check valve, click on the plus sign grip, and I'm going to right click and go to pipe fitting tool. And I'm thinking to place a double disc gate valve. And I'm also thinking to do a fitting to fitting connection. So fitting to fitting connection is done. I'm going to define the rotation of the hand wheel. And after that, I'm going to define the length of this pipe. And maybe I can do a little bit of auto routing here as well. So I'm going to connect this pipe to the node of this nozzle on the exchanger, and I'm going to select the first placement. After that, I'll do the similar steps on the other check valve. So I'm going to select the check valve, click on the plus sign grip, right click, pipe fitting, go to the gate valve, double disc, click place, and right click and fitting to fitting connection. And then in the end, I'm going to define the rotation of the hand wheel and connect this pipe to the pipe above. Okay. All right. So I'm not done with the component placement because I have to complete this network. I also want to draw a pipe run from this horizontal tank connecting to the pumps. But before I do that, let's say that at this stage I want to go inside the Navisworks because I want to do a little bit of the design review and fly through and walk through. I want to check maybe the properties, or maybe I want to check some clashes and things like that. So I'm going to save the drawing, and I'm going to open up the Navisworks software, and here I'm going to open that drawing in the Navisworks. So while I'm opening the software, the drawing in the Navisworks, I just want to quickly mention a couple of things here. First of all, you want to make sure that the object enablers are installed, because if the object enablers are not installed, then the piping components and the pipe fittings will show up as wireframe in Navisworks. So yeah, that's the first thing. Make sure the object enablers are installed. Secondly, it could also be a good idea to go to the options window here in the Navisworks and make sure the options for the file readers, DWG, they're properly set up. Okay, so I have the render type selected as shaded here. The faceting factor is 1 on a default installation of Navisworks, but you can play with this factor to have your surfaces look a bit more smooth. So I have changed it to 4 so the model appears in a good quality. All this information is documented in the Autodesk Knowledge Network pages, so you can always go to the Autodesk Knowledge Network and make sure that your settings are correct. As and when required, you can explore the options available there. I'm going to select the open option, and let's open the drawing, which is in the project folder, Plant 3D Models folder, piping folder, and here I'm going to change the files of type to Autodesk DWG, piping.dwg. It's opened up in a few seconds, and then after the file is open, you can go to the viewpoint, and you can work with the render styles, and you can work with the lighting mode and all the different things that you can adjust here. You can also use the walk tool to start walking. Okay. If you're using Navisworks, I'm pretty sure you're already familiar with these features, or I can also do the fly through to start flying through my model. I can also adjust the speed of the flying or walking. So I'm going to change the speed to 3 meters per second. And now it's a bit faster. Okay. I can go back in the home tab, and I can also work with the view cube, the navigation cube that we call, and rotate in different views. And I can also select the components, and I can also go to the selection tree, and I can start selecting the objects from the selection tree if I want to. I can start hiding them, isolating them, highlighting them, and I can start using all the features available in the Navisworks. Now, Navisworks obviously has a lot of features, but the intent of this webinar is not to demonstrate all the Navisworks features. The intent is to show you how the two software actually talk to each other. So I'm gonna select Clash Detective feature as an example to see how the two software are gonna talk to each other, and we'll take a look at the typical workflow involved to resolve the clashes and finding the clashes. So I'm going to click Add Test, and I'm going to add a test here. So let's say that this test is called Overall Clash. And after that, in the selection windows, I'm going to select the drawing name and highlight the drawing name here. I'm accepting the default as far as the type of the clash and the tolerance settings are concerned, but you could always modify according to the project needs and requirements, according to your own requirements, So I'm going to click on the run test, and let's see how many clashes it's going to find. And in here, in this table structure, the program shows us that I have 12 clashes as part of this test. So if I start scrolling through all these clashes, I can see that the majority of these clashes are actually the clashes between the structure components, the clash between the beam and the column in the Plant 3D structure. Now, if you're familiar with how you work with the structure module or structure components or commands in the Plant 3D structure, you know that you can go back in the piping drawing, in the structure drawing in Plant 3D, and you can start making some adjustments here by using the built-in miter cut member or cutback member tools available in the structure module. So you can adjust them, and obviously we don't have time to go and resolve each and every clash. So I'm going to pick on one of the clash available here, so that we can take that as an example to see what's the typical workflow involved to resolve the clash and to make the two software talk to each other. And I'm going to maybe work with this clash because this is the pipe that I just placed a few minutes ago, and I see that this pipe is actually clashing with that beam. So this could be a good example. Now, before I resolve the clash and before we see how the two software actually are going to talk to each other, I'm going to also highlight the fact that you can also right-click on the clash name, and you can rename the clash to make it a bit more elaborative. You could assign that to one of the team members, for example. Okay. You can also add the nodes, and not only that, but you can also define the status of the clash. So since it's a new clash, so the default status is new, but you can change the status based on the progress you're making as far as resolving the clashes are concerned. Now, before I resolve that, I also want to quickly touch on the fact that you can export these clashes to an external file format, and like in a report based on the file formats available in the software. So I can click on Write Report, and I can go to my desktop and save. It's going to take a few seconds, and when I minimize everything, I see that I have the HTML file format report available on my desktop. And in this report, I have a detail of all those clashes that I saw as part of that test. And this is the clash that I was picking on, that I was using as an example. And the notes and the assignment that I did is actually here. And if I click on the image, the program is also going to open the image in a bigger window, and I can take a look at the detail about this clash in the report. So I'm going to go back to my Navisworks software, and here I'm going to go back to the results, and I'm going to change the view to orthogonal, and then orthographic, and I'm going to now resolve this clash. And like I said, I know that this is the pipe which is clashing here with the beam. As you can see, it's clashing here. But just in case you're not sure that where exactly this component is available in your 3D model, or just in case your 3D model is huge and complicated and you don't want to manually zoom in and zoom out, you could also use the switchback feature in Navisworks. So the way you use that feature is you select this component, you right click and say switchback, and when you go to your 3D model, the same component will be highlighted in your plant 3D drawing in your 3D model, as long as the drawing is also open at the same time. So this component is highlighted, and I'm going to change the elevation of this pipe. I'm also while I'm changing the elevation, I'm gonna use the AutoCAD dynamic input feature. So I can dynamically change the elevation based on, center of pipe, top of pipe, or bottom of pipe, depending on my needs. So I'm going to use the keyboard tab key to change the focus to bottom of pipe, and I'm going to change the elevation. And now you can see that they're not clashing with each other anymore. So I'm going to save the drawing here at this point, and I'm going to go back to my Navisworks software, and in the Navisworks, I'm going to do a refresh. So it's going to, it's going to refresh the model. So when I do the refresh, after doing the refresh, I'm going to go to clash 6 one more time, and I'm going to do a little bit of rotating, and I can see that the components are not clashing with each other anymore. And I can, select the status of this clash as resolved. When I set it to resolve, you can see in this table of clashes available, I can see that I have one clash which has been resolved out of the 12 clashes. And I can also click on compact all, which is going to remove the clashes from this list that have been fixed, and it will leave only those clashes that still need to be addressed. So this is typically how you go about resolving the clashes, and that's how the two software are going to talk to each other as far as resolving the clashes is concerned. I'm not really done with Navisworks. I'm going to come back in the end of the webinar to Navisworks, and I'm going to talk a little bit about the properties, because I also want to show you a few tips to view some extended properties for the piping components in the Navisworks. Before I do that, I'm going to go back to my piping model, and I'm going to finish the component placement so we can create the, all the deliverables and everything that we want to create as part of this webinar. So I'm going to go to the pipe support spec, and I'm going to place the support, and I'm defining a filter, and I'm going to select this support, click OK, and I'm going to place the support somewhere here. I'm just eyeballing, but obviously you can change the views to to properly make some adjustments by using the snapping options or by using the grips available on the components. Not only that, I also can use the grips to change the dimension of the support, and now you can see that the support is actually exactly sitting on that structure. So yeah, I'm done placing this pipe run, and like I said, I'm gonna end this pipe placement or component placement by drawing a last pipe, which is gonna connect this tank to the pump. So before I do that, I'm going to hide this structure for the time being, because I'm thinking to draw that last pipe run using the center line, and I'm going to do the line to pipe tool in Plant 3D. So I have the center line already created. I'm going to place that center line. It's available as a block, so I'm going to place that from my drawing as a block. You want to make sure that you explode that block so it gets back to the it gets back to the line and it's not a block anymore. Okay, so I have the center line drawn, and I'm going to use the line to pipe tool to populate the center line with the pipes and fittings. Just want to make sure that I select the correct size and the correct spec, and line to pipe tool, and I'm going to select these lines. I'm going to select these two lines as well, and I'm going to I'm going to select this line. Just give me a second to select all of them. Select everything, and then I'm going to press the enter key to accept, and the pipe is now drawn. Okay, looks good. So I'm going to end the object isolation and hiding, so the structure comes back, and I'm done placing all the piping components and drawing all the pipe runs. I'm going to, in the end, just define a line number to this pipe run, because I want to use that to create the ISO drawing. And when we are creating the production ISO, the program is going to, it's gonna ask for us to select a line number. So I'm gonna select a line number as 1000 as an example. So line number has been assigned. When I hover the cursor, I see the line number in the tooltip. I'm going to save the drawing. Always a good idea to save every now and then I'm going to go to ISOs, production ISO, select the line number, and pick one of the ISO styles available, and then I'm going to hit the create button, so program starts processing the ISO in the background. So while the program is processing the ISO in the background, you can still carry on working on the model. You can zoom in and zoom out, which is great, because if you're creating the ISO of multiple different line numbers, you're not actually forced to wait until the ISO is processed. You can carry on working on your model while the ISO is still being processed in the background. And the amount of time the program is going to create to generate the ISO, that also depends on how much of information the program is processing in the background. So depending on the line that you're creating the ISO from, and depending on the amount of components you have on that line, it may take a few extra seconds. It may take a few less seconds. That totally depends. That totally varies from time to time. And line to line. So when the ISOs are drawn or created, you'll get a notification here in the lower right corner. You click on that message, and this is the ISO drawing. When the ISO drawing is open up, and this is a typical example of an ISO generated from the Plant 3D. Everything is properly dimensioned, properly annotated. You can control as part of your customization and set up the amount of info you want to see on the ISO drawing. That's your bill of material tables, customizable. That's your cut piece list table. And this is the well list table, and you can also have, as part of your implementation, your own ISO style setup, having your own title block in your company's logo and stuff like that. So that's an example of the ISO drawing. Let's go ahead and create the orthographic drawing, which is like creating a 2D projection. So I'm going to create an orthographic drawing, and I'm going to define a name. So let's say the name of the ortho drawing is ortho. I'm going to click OK. And the program shows me my model in the ortho cube. So by default, you'll notice that it only shows me the pipes in this ortho cube. So I want to make sure that I select all the drawings. so that the components coming from the reference drawings, they also show up in the orthographic drawing. I'm going to click OK, and after that you can make some adjustments to the length, width, and height of the cube, just so everything comes inside the cube. So you can do that by using the grips available on the ortho cube. I'm going to make some adjustments, and I'm going to make some adjustment here as well, because I saw that the components were actually going outside the cube. Now, before you click the OK button to create the viewport, you can work with these tools available to make sure that to select if you want to see the hidden line piping or not. You can enable and disable the match lines and cut pipe symbols. You can define a scaling for the viewport. You can click on paper check, which is when the program is going to show you the the size of the viewport in comparison to the paper size coming from the orthographic drawing template. If you think that the viewport is going to be a little bit too small or too big, you can make some adjustment to the scaling. Hit OK, and you can place that viewport on the ortho drawing, and program is going to query the geometry, query the drawing, collect all the geometry, and show you a 2D projection from the top. Once the viewport is generated, you can start annotating the component using the out of the box annotation styles available. As part of the customization or your project setup, you can also modify these annotation styles or create new annotation style if there's a requirement. You could also use the text and dimension tools to add some more information on the viewports. And while you're adding text and dimensioning, you'll be working with the same tips and techniques that you're already familiar with, because this is the same text and dimensioning that you see in AutoCAD. If you want to create a report with a proper formatting, you can go to the Plant Report Creator tool and load your project, and from here you can select one of the report templates available, and you can create the report in your preferred file format. So my default file format here for creating this report was Excel, but you can also choose to create that in a different file format, like a PDF or a Word document or a JPG file or image file. You can choose to send it directly to the printer. I use the default, so it has the Autodesk logo, but you can customize this to have your own company's logo as part of your needs and requirements. Okay, so in the end, I'm going to go back to my Navisworks, and I'm going to talk a little bit. I want to touch a little bit on the properties, like the kind of properties that show up in the properties window, and how you can view some extended properties in the Navisworks software. So I'm going to open up the properties window, and I'm going to select this pipe, for example. Let's select this pipe, highlight this pipe, and I can see that the program shows me here some properties in the AutoCAD tab, and these are the properties which are coming from the Plant 3D piping model. Okay. If you want to see some extended properties available, the trick would be to, in a DWG file, you don't see that extended list of properties available. So the workaround or the trick would be to export that piping model to a DWF file format. So the way you do that is you go back to your piping model, and here you type 3D DWF, and then you actually export your piping model, your DWG file, to a DWF file format. And then you go back to your Navisworks software, and here you go to the open, and I'm going to go to the desktop, and I'm going to select the DWF file as a file format, and this is the file I just created a few seconds ago, and I'm going to open that DWF. And when I click on this pipe now, you can see that you get to see a lot of extra properties in the properties window under DWF pipe tab. Okay, so which is not normally you see when you're just opening the DWG file. So if you care about having having a live link, then opening the DWG is the way to go, like we just did in this webinar. But if you don't care about having a live link and you want to see some extended information, some extended properties, then this is the way to go. You can export to a DWF file, and you can use that as a workaround. Well, this is pretty much it in this webinar, and this brings me to the end. I know that some of you have asked questions, but we have run out of time. Like I said, we will still be getting in touch through emails with all those who ask questions and try our best to answer your questions. Meanwhile, if you come across any further questions or concerns about the products, please do not hesitate to reach out. If you would like to have a discussion, or if you need some further information about the products, with just a phone call or an email away, our contact detail is displayed on the screen in front of you. Once again, thank you for registering and attending. and we look forward to hearing from you. Stay home, stay safe. Goodbye.